Hi everyone. Let's continue where we left off before. Before we get into the third principle of experimental design, I just wanted to clarify a couple of things. First of all, I wanted to correct something I said earlier. I realized a little bit later on that I should have chosen my words more wisely when I was talking initially about lurking variables. So earlier I mentioned that, or I talked about possibly eliminating or getting rid of lurking variables. You obviously cannot get rid of a lurking variable. And I'm hoping that as you've thought about some of the examples we've talked about so far, it's clear why that's the case. You might be conducting an experiment, perhaps, think back to the diet experiment that we talked about a little bit earlier, where we think that the type of diet you're on can affect certain health outcomes, and we know that there are other lurking variables that could also affect those health outcomes, like age, genetic factors, maybe gender. Obviously, those are things we cannot eliminate. We can't get rid of someone's age or take away their genetic background. So those are things that are always going to be present. We just have to be thinking about those things as we're designing our experiment. We have to think about other factors that could affect the outcome over and above our explanatory variable, and we need to figure out a way to build them into our study and to control for their effects in a particular way. And this can help us in terms of trying to figure out, again, at the end of the experiment, what is actually leading to the response. We want to be as confident as we can be that anything that we're seeing in the response or any differences we're seeing among the groups is hopefully because of our treatment or our manipulation and not because of these other things that we did not control for. So that's one thing I just wanted to quickly mention. We cannot eliminate lurking variables. I should not have said that earlier. I also wanted to clarify that when we talked about control, I spent a lot of time talking about how random assignment is a way for you to control. It's a nice way for you to try to mix up those lurking variables in a similar way among your treatments so that at the start of the study, all the groups are hopefully very similar in terms of those variables, and then the only thing that's going to differ, ideally, is the treatment that you're applying. There are certainly other ways to build control into your experiment. And so keep in mind that when we're talking about control, we're talking about trying to keep things consistent from treatment to treatment so that, or from group to group, so that what ideally is hopefully the only different thing among the groups is the treatment that you're applying. And then again, when you see responses, you can hopefully be more confident that they are because of that treatment and not because of these other things. So just as an example of other way of controlling, let's say that you have an experiment in a laboratory and people are coming to your laboratory to take part in this experiment. You would want to make sure that you give similar instructions to each person, that the instructions are read in a similar way, that the lighting conditions are the same, that any background noise is the same. Unless those things are part of the experiment, you would want to keep them consistent from person to person so that someone's not going to be able to come along at the end of your study and say, oh yeah, of course this group did better. Not because of the treatment, but because they had much better lighting conditions than this other group. So there are lots of other things that you want to try to keep consistent and control for. So when we talk about control, again, it's trying to make things consistent so that hopefully the only main difference or major difference among the groups is that treatment that's applied. Okay, so hopefully that is clear. Let's talk now quickly about our last principle of experimental design. And this principle is that we want to use enough subjects. So what does that mean? I wish there was an easy answer for this, but we always want to be thinking about the number of subjects that are going through our study. And why do we want to have as many as we can? Why do we want a bigger sample size? I'm hoping that as you're thinking back to what we talked about earlier, especially in chapters 2 through 4, when we were talking about samples and sample size issues, that you're thinking about what happens to our margin of error when we have a larger sample. We are trying to get as close as possible to the truth about what's going on in the population. And if we take a large random sample, hopefully that can help us get closer and closer to what's actually going on in the sample or in the population. So again, we're using a sample to say something about a population. Remember that as we increase the sample size, so if we all took large samples and we looked at these sample statistics, so let's say each of us takes a sample of size 100 from all OSU undergraduates, and we figure out the average age of our sample. As our sample sizes increase, our sample means should get closer and closer to each other, and they should get closer and closer to whatever's true about the population, to the true population mean. So having a large sample size can help us reduce variability that we would see from sample to sample, or even within our own sample. That can help us reduce variability, and that point will hopefully come up, or that point will hopefully make more sense as we get further into our content, especially as we start getting into chapters 10, 11, and 12. What is enough subjects, you might be asking? So I need to have enough. Well, what is enough? What sample size should I strive for? And that's where things get a little murky. I can't tell you this is how big your sample should be. Certainly it's going to depend. What's large enough is going to depend on a lot of different things. You might be studying something, for example, where there just aren't a lot of individuals that you have to choose from to be a part of your sample. Maybe you're looking at some sort of rare disease. Not a lot of people have that disease, so you maybe aren't going to be able to get a very big sample. So it really depends on what's large enough. We can't give you a number. We can't say you should strive for a sample that's this size. We just want you to be thinking about why bigger is better. We want you to be focusing on the fact that you want a big sample. We want you to be thinking about what that does for you. As the sample size gets bigger, what sort of benefits do we have? What does that do? And again, that if you've done a good job of taking the sample and the sample's representative, as we get an even bigger sample size, we should get closer and closer to the truth about what's going on in the population, and we're going to reduce the margin of error. So again, later on, as we go further into the content, especially as we get into chapters 11 and 12, where we're going to talk about summarizing data and graphing data, this will come up again. So and even beyond that, you're going to start seeing more and more why a larger sample is better and what kinds of things that can do for us. But when you're critiquing a study, just think about the sample size. Does it seem like that we could have had a bigger sample? Does it seem like the sample size is large enough to be okay? Should we be concerned about conclusions we're drawing based maybe on too few individuals? So just be thinking about these things. And again, your textbook does a nice job of also laying out why this is important. So please be sure to definitely read through that in the text. So let's put some pieces together here. Oops, I feel like okay, you know what? I just realized that I totally kind of skipped over something that's important that I meant to go through actually before we even had that whole discussion about sample size. But I just quickly wanted to share with you some other studies, just as a quick example. How tattoos affect your workout. So there are some researchers who feel that having a tattoo on your body might change the way your body perspires, might change how you sweat. Your dusty house is making you fat. So I saw this and I thought, I'm never going to be skinny. If that's the case, my house will probably always be dusty. Walnuts could help you fight food cravings, a study shows. A new study says that taking a hot bath burns as many calories as a 30-minute walk. So I meant to show you these before we started this discussion on sample size, just to try to convey that all of these studies actually made the headlines. So I have links here where you can actually go and read a little bit more about these studies if you want. And, it's possible that some people just sort of skim the headlines, they see it, maybe they read the first paragraph, they don't actually read the full story. All of these particular things, they give us really sensational headlines. But if you learn a little bit more of the details of each of these studies, you're going to find that in this first study, the sample size was 10. 10 men actually participated in the study, healthy young men. In the next one, they looked at 11 houses. all in North Carolina. And the study actually, when I first saw this, there was a picture of a woman and she was cleaning. But when you read the details of the study, this study wasn't actually even performed on humans. They had mice as subjects in the study. This one was all about, or this particular study had 10 obese individuals were participants in that study. And this one had a sample size of 14, again, all men. So obviously there are some limitations here. These are pretty small samples, yet we're making rather strong claims about things that could be going on. So these are things that we want you to start being critical about. Start looking for those kinds of things. How big was the sample size? Should we be concerned that maybe the sample was too small? Maybe the sample's not really a good representation of the population. Should we be careful in terms of what we're concluding? Should we be cautious in our conclusions? So hopefully this is making some sense as to why this is all important. Okay, so let me quickly go through here now. So putting the pieces together. So here we're just going to talk about all the things that we've talked about so far, all the different terms and concepts. There was a dog food commercial all about Purina dog food. So I have some dogs. I have a couple of dogs, and I was very interested in what I was hearing in this commercial. And here's just a direct quote from the commercial. A study proves that Purina chow, so Purina dog chow is a certain type of dog food. A study proves that puppy chow, then dog chow nutrition fed properly over a lifetime can help extend a dog's lovable antics up to 1.8 healthy years. So of course we all want to have our dogs as long as we can. Having a dog for even longer, that's good to me. That sounds good. Should I buy this particular dog food? Well, I want you to think a little bit about what kind of experiment would you expect? So this is a pretty strong claim. They're using this word proves. And so that to me is a clue that, did they do an experiment of some kind? Did they control possible lurking variables? How were they able to prove this? I want to know what this experiment looks like. And I just want you to think a little bit about what an experiment should look like in order to make this particular claim. What would you expect that the researchers would have done here in this study? Maybe you're thinking, well, we'd want to look at all kinds of different dogs. We'd randomly assign some dogs to get one particular dog food, other dogs to get the Purina dog food. We'd obviously have to follow them for a certain amount of time, maybe their whole lives, to know just, does the group who got the Purina dog food live longer on average than the other group? So, that sounds like maybe a possible study that could have been done here. Let me pause this and we'll come back and I'll tell you what was actually done and we'll critique that a little bit.